All right, so I want to introduce and talk a little bit about the web services. All right, so um, I might spend one or two lectures talking about this one here, and then simply because we did not really have any of the course. I think now we do. There is, I remember, a 499 course on the web services, but most of you probably never took it. It's not a required course. We do not have the time to really talk all the details about this one. I think the web service itself can be a whole CS course. It's going to be a very interesting course, but we don't have really the time to cover every single detail. So I just need to give you the overview about what web service is, what are the key components, and then you guys really need to spend a lot of the time to learn these things by yourself. Okay, so I never said this project is easy. And then I never assumed that you all have the knowledge on web service. In fact, I know that 80% of you probably never work anything on servers and web service or front end stuff. So, but um, just want to give you some confidence that over the past 5 years, I have never seen a single team who cannot deliver a web service project at the end. That never happens. I had so many team members stop by in the beginning and said, "Oh, I have no experience. Can I do it? What should I learn? How do I get started?" In the beginning, it always seemed to be a lot thing to learn, but there is a learning curve. It's not really too bad. Okay, after I think 2 or 3 weeks, if you start looking into this topic, it's really interesting, very practical, and you're gonna learn so much. All right. So, but I will just give you some of the background about web services. All right. So let's take a look at some of the concept. All right. So what is a web service? I think this is a really good definition. All right. So it's a method of communication between two electronic devices. Okay. It doesn't really have to be two, multiple devices. And then you do the communication over a network. All right. And so it is also a software function, um, that provided at this network infrastructure. Another important thing is the service is always on, right? And then also it has something to do with this kind of a utility computing, right? So some of these keywords, okay, so this is actually a very formal definition, but it really highlights some of the very important uh, features about web service. So it deals with communication. Okay, we'll talk about how we do the communication. And then you use the network to do the communication. And most of the time we're talking about internet. And then there is a software that serves all of this, and the service always on. That's very important. Now, most of the programs you have been writing today in Java, in Python, you just click on the button to run it and get a result. That's it. But web service program, you need to make sure it's always on because you never know when the user is going to come and to use your service. So that's why it's just like a utility, right? Your water, electricity at home, whenever you need to use that one, you turn on. And then if you don't need it, you can turn it off. But the water and power company, they're always open. All right. So that is the concept of web service. All right. Examples, pretty easy to understand, right? Google, go to the page, type a keyword, click on a button to search, right? Looks like the UI very simple, but once you send your keyword, and Google will receive it by providing the actual searching service, and it looks for all the database and then return all the relevant results and send it back to you. When we are using Google, at different time, we're sending different keyword. The result, the page we're seeing are all different. Okay, so that is an example of web service. Facebook is another one. All right, everyone keep track of your own profile, your own photo, your own stories, and then your own friends. And then the pages, the content you're seeing, and messages you're seeing are all personal and customized, right? But everything has been hosted in Facebook. You just go and log into their service to use and retrieve all this information. And weather.com, another very simple and straightforward web service. It gave you all this information and you can query. You can query by location, you can query by date. You send your search criteria and then they give you all these responses. Another good example is or like a scheduler service that you query the schedules forces, and you can type the days and professors, all this query input, and then it gives you all the result back in the web pages. So it's also a web service, right? So one thing keep in mind, the difference between web service and website is when we're talking about a website, most of the time we're talking about like a static or content-based a website. You go there, you can see all the information, such as if you go to our CS department website, right? cpu.edu/CS or something like that. And then you see all this faculty introduction, program introductions, research, all the student activity, all of those, right? So we just update all the content there, put it there. So everyone go to the page, you see the same thing. So it runs on the server, but it's just a static website. All right. So for this project, for this course, we do not want you to build a website, okay, static website. We want you to build a web service application. Okay, so that means it's, as I mentioned, it provides communication, serve purpose, always on, and then it provides customized content based on the functions you're doing. All right, so that's the key difference between the two. Also, if you look at other internet companies or mobile companies, and you can't really do anything without web service today. I see Uber, right? So it isn't an app, but obviously they have their own web service application, their server program running there in the backend, and you can search for all the nearby drivers. You can find all the drivers. You can send your request based on your location and your destination, and then the server will be able to calculate the rate, will be able to match the drivers, and then to handle all the transactions. So the app you're using is just a front end. You see the UI, you see all the button, you find a way to interact with the server, but all this logic actually happens in the backend server program, right? So same thing as our project, as I told you, you can actually have an app. However, you still need to have a backend service, and also you should also have a web front end. So I would say the mobile app client will be a plus, but you need to have your foundation first using the traditional web technologies. All right, so this is a very typical structure or architect for web service programs or web service applications. All right, so basically you have this middle part here, which is the web service program. Okay, normally we call it server program, or you can call it backend program. All right, this one actually is normally connected to a database. All right, so we'll talk a little bit more about the options here, such as MongoDB or traditional relational database, MySQL, or Microsoft SQL Server, all of those. And some of the newer ones, besides MongoDB, you can have like a DynamoDB, Cassandra, GraphQL. I know a lot of these new things. I can't really follow all of those technologies. Because most of this web service are going to deal with some kind of content and data. We need to save and manage a lot of data. So that's why you normally need a database. And database could be a separate program. Of course, you can also build your own database inside a server, but that's not very common. All right. So, but in the whole backend, this whole web service program connects to the database. And then the user interact with the web service through some kind of front-end interfaces, such as the mobile apps or a website. All right. But those are only the front-end UIs, just like windows and buttons. And then that provide a way for us to send our command, send our request to the server as a request, and the server will send the response back to our interfaces so that you can see them. All right. So we normally call this kind of a 3-layer architecture. Okay, database, that's the bottom one. And then the backend web service server program is the middle tier. And then the front end is the tier that faces customer directly, right? So, but obviously this web service, sometimes when we say a web service, we're talking about this whole thing, but the most critical component is actually this web service program. And sometimes you have this related, but your project could be like containing all of them together. You can put all the front-end pages in the server and database all together in one project. That's also pretty common, especially when your service is not really too complicated. All right, so these are the examples. So any questions so far about the web service basics? All right, let's look at some examples. All right, so this is an example I use to use. Okay, the short URL service, but I really don't like it anymore. It's not very interesting, and also because they changed a lot of the service, I don't think this one's still working, right? So I'm trying to give you a different kind of example on the web service. So I want to use this Google Map, the places search. Okay, so for example, let's actually go to Google Maps, right? So everybody using this one. All right. So this is pretty convenient, and then you just do and go search for anything you want location. So let's just talk about searching for places, right? So you go here and search for restaurant, and then you basically get all this result return, and then you can see all those result in the front end page. All right. So the Google Map is a very typical web service. As I mentioned, it's a service provided by Google. Now you are interacting this one with the web browser in the front end, and you can view things. You can also send your customer requests, such as searching for a restaurant. And then Google get my request and then query Google's database and return all of those restaurants nearby to me. And then my browser receives those responses and render them nicely in this kind of a layout so that you can actually click on them and then figure out the details. All right, so that's how things are working here. All right, so this is a web service, but now I want you to think about exactly what happens. All right, so the web page we're looking at just a front end, but under the hood, what really happening is the moment we're typing a keyword and clicking on the button to search, it actually sends out a request to Google server. Now, for those of you who know more about web service, we're actually sending an HTTP request, right? And then once Google get the request, Google will know the keyword we're sending, and then it will do a lot of searching algorithm and find a result. And then Google will send back a HTTP response to us so that we can see all this result here. All right, so there is a request response. Okay, let's try to search one more. If I search for bar, all right, and then it's another request, another response coming back. All right, so understanding that request and response is the first step when you start to learn the web service. All right, so let's actually take a look at exactly how that request response works. So I mentioned it's actually HTTP. So that's why I showed you this page here. Now, if one day you want to do something about this one, Google actually open the whole place search API to you so that you can actually use this one. All right. So they actually provide you this documentation on how exactly to use this API to search for different things. Okay. So basically what happened here is, let me actually make this one a little bit bigger. All right. So they have a font place request API, something like this. All right. So as you can see, this is basically URL. We'll talk more about a URL. And the URL has a domain name and then has a bunch of slash, the path, and then you can put more parameters. So basically you can use this one to search and find for places. And then of course you can send a lot of parameters such as a keyword, the input type, all of those. All right. And then there are a lot more details. All right, so these are some good examples. Let me actually try to run an example. But I think this one need a key, right? That's something I need to set up. We're trying to find a key I had, but okay, give me 1 second. So Google Cloud. This is the service that you have to pay by having a Google Cloud account. Previous, a lot of the map services are free. Right now, I think you have to pay for them. All right, so let me see if I can enable one of this one here, okay? So, so basically you need to go to the API services, find out the Google, all right. Let me actually find, enable the APIs and services. All right, so let's try to go, yeah, maps, places. I think Google, that's that one, yes. So Google Places API. Let me enable this one here. It's actually not really expensive. I think if you look at the pricing, it's like thousands of requests, probably only cost you certain cents. But then you do need to set up the billing and everything. All right. Okay, so I think this one has been enabled. Okay, I think this one enabled, and then I need to go to credentials and then get a key here. Okay, so I do have some keys. Let me see if this one works. Okay, looks like this one is working. Okay, let me actually give a test very quick. So I'm gonna find this one here. Okay, and then put it here. All right, that's a long URL. Okay, so let me actually get something here. Okay, so I'm gonna put my API here. Here is the API. All right, so this is the long URL. Let me try to run it, see what happens. Let me make sure it works. All right, I think it works. Wait, let me see. Yeah, I think it works. All right, so let me show you this one, guys. So I set up the key. Okay, so now let me actually show you how the API works, the HTTP API. So, you know, any of these providers, such as Google Maps, they give you exactly how you want to call this one. All right, so let's take a look at this API here. I'm gonna go back here. Let's make this one bigger to see what's going on here. So this one here is the HTTP request you can send to the Google server and get response. And then this API here had this part here first, which is the kind of the position of the API, the server, the domain name, and also the API path. All right, and after that, you have a bunch of parameters. You got input, right? So the input here has a Museum of Contemporary Art Australia. This kind of that I think that's the keyword. And then you got another input type, which is the text query, meaning that you're typing some of the keyword in text. And there are some fields talking about the things you want to return. You want to see the photo, you want to see the format address, you want to see the name, rating, all of this. If you don't want all of this, you don't have to write all these fields, right? And then finally, you got a key, right? So for example, let's try this. For the input, I don't want to do this one. I will try to search for Cal Poly Pomona. All right, so I'm gonna copy this URL again and then go to my website here and try to do a query. All right, so here's the result. All right, so as you can see this time, I got this kind of a data as a response. Now, for those of you who are familiar with data, this is JSON format, right? So we'll talk more about the JSON format. But this come back from Google server as a response. All right, so we were trying to query Cal Poly Pomona, and now they gave it to us. So as you can see, they gave us the formatted address. That's our official address. They gave us our location, the latitude and longitude. They gave us some of the viewpoint. I think some of the viewpoint, I don't know, that's maybe some specific point for viewing the location on the map or the campus. There's the official name, and also give us a bunch of photos, right? So we want to take a look at a photo. Not sure if we can view this one directly. But you know, that's just one photo that you can get from the server, and also the rating. All right. So this is the response from the Google server. But then this time, as you can see, it's different, obviously, from here. So here, if I do Cal Poly Pomona, and then I will be able to find this pin here, see all the UI here. However, before I see everything, the main thing happening in the background is this request. Okay, you're sending a request to Google server, and Google server gave you this JSON format. And then once the format reach out back to your browser will be able to render it. Okay, so for now, I want you to have a kind of a clear understanding that the purpose of the building this whole web service, you know, your very first step is to enable all of this communications using HTTP requests and responses. All right, so let me give you more examples. Going back to this Google Places API. All right, let me try different things. Like here, you can search nearby requests. So for example, in many cases, I want to search the nearby coffee shops near Cal Poly, right? So they will tell you exactly what to do. For example, you got a keyword again, and then you have some others like where the nearby how do you provide? Yeah, here, location. So what is the location of you're talking about nearby, where you are standing right now, and also the radius. All right, so let's try this one here. So is there an example we can use? Okay, so here example, very good example. I'm gonna copy it over here so you can see it. So again, this part is the nearby search, and then the location, that's the longitude somewhere, and then the radius is 1,500, I don't know, kilometers and miles. You're trying to search restaurant, and then the keyword, all right, and then the API key. So let me actually get my API key here, okay? And I'm gonna do something nearby, right? So let's go to Cal Poly Pomona. I think our latitude, longitude, let me just get an estimate. So I click on here. So that's our geolocation. Geolocation, and then here. All right, so radius, let's do a little bit less, just do 50. And then let's try to search for a restaurant. And then keyword, okay, so I'll do burger. All right, so going to this API now, going to my browser, and I paste the URL here, hit enter. Oh, no result. Okay, maybe the burger is not right. We'll just do coffee. Or maybe this radius is too less. Okay, so try this again. See, did I do anything wrong with the geolocation? Or maybe I put the radius bigger. Okay, 1,500. One more time. Yeah, I think for somehow the radius was too less. Okay, so looking for coffee, and then something's on close. What are these? The Einstein, that's on campus. This one, this is the first one. And then what's the next one? Oh, this is the same place. And this is, what's the name of it? I didn't see the name. Where's the name?
Is Starbucks up there?
Starbucks? Where? I
Yeah.
can't see the names. Oh, okay. Yeah, so name is right here. So it basically just returned a 2. We only have 2 coffee shops nearby. All right. Anyway, so you can see this result all coming back, and based on the search, obviously you can adjust all the search parameters and then get a different result. Okay, so that's really what's happening under the hood. Okay, from the communication level. Now the reason you can have all of this is because Google has built a web service program on their side. They have a host that running this program. They expose this API so that you can call this one HTTP and then get all the result back. Okay, so the HTTP request response is really the key to understand when you try to build a web service. All right, now coming back to the slides, okay, when we talk about HTTP, there are really 2 things you need to understand. So the first one is what is HTTP, right? So HTTP, let me see if I have a slide here. All right, so actually let me talk about the second one first. So the JSON data, this is a very simple concept because you already saw it. So once you are communicating with the server, and you will need to communicate with data. You send the data, you receive data. Primarily, you're gonna get a response data from any kind of web services. Then we need to follow some kind of a format of the data. Now, JSON is the data that we use most often, the format we use most often. And then JSON, if you never heard about JSON, you really need to take a look at that one. Okay, it's the most popular data format we use today because it's very concise. It's very easy to understand. It's key value pairs. It's just like a hash table. For example, you already saw here. All of this result is organized by we call it a key and also a value. For example, the key is the name, and then the value will be the actual name value. And this one is a status called a permanent close, and then this is true. That means it is closed. And you got a key for photo, and then you can have a list of photos here. All right, so this is the JSON data. Whenever you see these brackets, colons separating the key and value, these are JSON format. So I would say, 80% of the web server today use JSON to communicate, right? Because as I mentioned, this one is very concise and also it's very readable, okay, very easy to understand. And also you can easily map this data to any kind of objects using Java, JavaScript, or any kind of language support JSON really well. In the old days, okay, people don't use JSON. Does anyone know what people were using like 10, 20 years ago? Another format. You will still see that format these days, but just definitely not very often as before. XML, yes, that's correct. So XML, if you've never seen that. All right, so that is XML. You've probably seen that somewhere. Okay, you didn't, let me find a more clear view. So this kind of a tag data format, right? So around 2000, I think IBM designed and innovated this format and also all the services stuff. And then it was a big innovation. Today, when you see JSON, you don't really see that's a new technology. But back in 2000, this whole XML is a big deal. IBM makes so much money using XML and also the web service stuff, right? But then the reason with XML, that XML is really no longer popular is because it's very hard to write. Okay, you got all the tags, and you have this attribute embedded. You always have opening, closing, writing a lot. It's very easy to mess up. It's not very readable. But compare this one with JSON, as you can see, JSON is so much more clear. That's why this one quickly become the most popular way to wrap all the data. All right. But the JSON format is really, really simple. Okay. Don't worry if you never heard about this one, you don't know what that is. Take a look at documentation, go to like W3 schools, find out JSON tutorial. You'll learn that within 5 or 10 minutes. That's it. All right. Yes, Android Studio still use XML for their manifest file and also their UI layout. So there, definitely some places, but for communication, I see, especially the new services, pretty much it's all JSON. All right, so that's how you deal with the data. There, you have to choose one format, whether it's JSON, XML, or some other your own defined way. But in general, we try to keep it very standardized. So JSON will be your first choice. All right, once you understand the data, so how are we exactly sending and receiving all the requests? I mentioned it's using HTTP protocol. Okay, so what is HTTP protocol? All right, so and that's basically something that every time you go to the website, right? So you go to our CBP or whatever, you go to the URL, but the actual full URL is HTTP : / and then this URL here, right? But you don't have to type HTTP, but because by default in the browser, we use HTTP protocol. All right, so the protocol is basically like a set of rules to specify how we should communicate using the internet. I think the best example to understand that is think about highways, right? So when you go to highways, you have to follow certain rules. Otherwise, we don't know how things should work because just like highway, the internet, all the cables, they're being shared. Like every time your internet provider, their cable has been used by all millions of users at the same time. We're all sending different things to different places. Some of you are playing games, some of you are Google, some of you are doing other things, right? So we're sharing, but we don't want to interrupt each other. That means we need to follow certain rules. Same thing for HTTP. Just like also like a highway, when you drive, you have to follow certain rules. Where do you get onto the highway? How can you take exit? How do you want to pass a car? All of this speed limit, right? So all of these rules. So if you don't have a rules, then we cannot really do the communication. And then people must agree on the rules. Right? So that's the purpose of the HTTP protocol. So HTTP protocol pretty much specified a bunch of rules and the things you need to follow when you are sending and receiving all the requests and response. All right, so let me actually use a specific example to talk about some of the key things you need to know about HTTP. The HTTP itself, okay, is a very complicated specification. So if you want to find out exactly what HTTP is, so you can search for HTTP specification. Okay, there is a very official documentation right here. Okay, you guys can take a look. and this all like text-based. Okay, this one just the content of the table. But if you want to see the full, there should be a place where you can open the full text. They don't have it. Let me click on one of this. Yeah, they break down into the pages. I remember in the old place they have everything together. This one is I don't know how long. This one like hundreds of pages probably. If you want to read this one, it probably takes you months, okay, to really get all the details. But this one does specify every single detail on all the sending requests and receiving response, generating response, how things should work. And we always don't have time to read every single one of this, but I just want you to understand the most important three elements. All right. So when we're talking about HTTP protocol, okay, let's use this example. Okay, you go to Facebook, try to log in, and from there you already started to do the HTTP communication. All right. So this is something I mentioned, that to understand the protocol, you want to understand a few things. All right. What is the syntax? All right, you're sending a request. So what are the content you should send in the request? What kind of format, syntax, grammar you should follow? And semantics. So what does it mean for each of the component? Why you're using this keyword? And where do you send? What does it mean if you put this parameter? And also the timing. So what is the sequence of doing all the communication? So these are the things you should keep in mind about understanding any kind of a protocol. Besides HTTP protocol, does anyone know any other protocols? Some of the popular ones?
TCP.
Oh, I'm sorry.
TCP.
TCP protocol, that's a lower level network protocol that supports HTTP, right? Very good. Anything else? Yeah, FTP. FTP, it's a file upload, file transfer protocol, but it's not popular anymore. This one is more popular in the early days of internet, because that time the internet was not very fast, and it takes a lot of time to download and transfer files. So at that time, people were mainly using the FTP, but now I think it's actually mostly done by HTTP. Yeah, the SMTP is really important because for email sending, and the SSH obviously also very important. That's for you to remotely access the control. So we'll talk some of this one in the near future. Very good, guys. All right, so these are some other protocols, but HTTP obviously is the most important one. All right, so here is a typical HTTP request and response. All right, so as I mentioned, when we are sending that request to a server, we are actually sending things like this. Okay, this is what a request will look like. So you will need to specify something called a GET, and then you specify the page, the path you're trying to get, the HTTP version, and then some of the connection, accept header, user agent header, host, basic domain name. So a lot of this information, you put that into the request. That reach out to the server. The server will give you some kind of response. The response will always be like this. There's an HTTP header and then 200 response code saying that is okay, which means successful. After that, it tells you which server tells you that response, what is the content location and the content type being sent, and also some of the data attached to it. All right, so again, we're not trying to learn the HTTP syntax, but I just want you to know, at least have a feeling on what the syntax looks like. Okay, it's all text-based, and then you can dig into all of this HTTP requests, you can find out how they works. All right. So yeah, so basically, that's basically what happened. You are sending a GET request. We'll talk about what is a GET request to the Facebook server, and Facebook server receive it and then see that you haven't logged in. So they will send you back a response to saying, okay, now you can actually start to put your your username and password. And then you can do another one to sending the username and password. Once being verified, it will send back to your homepage and to show all the news feeds. All right, so it's all of this kind of a rounds of communications between the servers and your client, your computer. All right. So one more thing concept here, very important, is the HTTP method. All right. So I showed you this GET keyword in the HTTP example, the request example. So in every single HTTP request you're sending, you must specify this request method, whether it's a GET or post or something else. So here are the most commonly used. Actually, no, these are all the supported HTTP message. Okay, so get, post, delete, put, head, trace, all of those. Most of these are not really used very often, but the one you normally use, number one is a get, number two is a post. And sometimes you do have a delete, but get and post is probably the most commonly used one. All right, so this is one. Okay, let me back to the slides here. So this is where you use the keyword, the message. It's basically the beginning of your HTTP request. You have to put this keyword there explicitly. What is the method you are using? Okay, so this one tells the server what are you trying to do in general. Okay, so very easy to understand. Get means that I want to get information. I want to retrieve information. In other words, I want to read information from your server. Where post specify that I want to post a message there. I want to save something on the server. I want to write something on the server. Okay, the key difference between the two is this is read and this is write. This one is not going to affect the content of the server, where this one is going to modify the content of the server. All right, so that's really the key difference between get and also the post. All right, so the basic example, if you go to Google search, you're basically sending get request. I was searching the restaurant, I'm also sending the get request. The best example about a post, you go to Facebook, you add a photo, you upload a photo, that's a post request. You go to Facebook, you modify your profile information, that's also a post, because every of those actions will cause a change on the server. All right, so every single request you're trying to use, you need to know whether it's a get and post. So that means when you are writing your own web server program, you also need to know for every single function you're giving users, should they use a get or post request? All right, so this is definitely one of the most important concepts you need to know, because later on you will see when you start to program a web service, for every function, you must specify this get and this message, whether it's a get or post or both. Delete is easy to understand. If you try to delete things, then you can specify this word delete. All right, so that is how the request method works. It's mostly a specification, but it's a very important concept you need to program in your own web applications. One thing I don't want to comment on this one is that this is a guidance, so it's not really required. So what I mean by that is if you are sending a GET request, but you're still modifying the server, that's okay. If the server supports you doing that one in that way, it's okay. It's not really completely follow the standard, but the HTTP is not going to verify that. So because it's all depend on what your server is trying to do. So as your server developer, basically when you guys are building your own web service, you should try to make sure that if your function just trying to do the read, and then you should actually let people to use the GET request rather than the post. But if your function deals with writing and changing the data, then you should enable the post request, not the GET. All right, so it's just a best practice. All right, so another part of the request you should know is this URL you're sending, right? So in the HTTP specification, we call this resource, right? So the way to specify the resource is using URL. So that's why URL means the Uniform Resource Locator, right? So this is a very easy, simple concept everyone being using, familiar with it. It's really easy to understand because it just specifies a position, right? So I go to facebook.com, I know that's their server, not Google server. And I know I'm looking for specifically this page, all right? But you need to know more about the URL because the format we're using normally is a concise one. The full version of the URL contains these major parts. The schema is the protocol, actually HTTP, sometimes HTTPS, or some other things. And then the server is the domain name, and that's the one you must have every time. There is something that we don't normally put, which is a port number, right here. Okay, so it's separated by colon. All right? But most time, the reason we don't specify the port number is because we're using port 80. So for HTTP, normally by default, the port is 80. So if it's 80, then we can just ignore it, just for developer to, because that's the most common use, the port number, so you don't have to specify every time. And then after that, you got another slash followed by all the paths to the specific resource. Okay, so this is the complete format of the URL. So now if you come back to this one here, all right, so the one we're just using, schema here, domain name, this part here, server and host name. In fact, you do have a colon 80. I just didn't write it because default it is 80. And this hosting here is the path to the resource. And then this one is also part of it, but it's more specifically to the parameter, to the input. All right, so that's 4 components for the URL. Schema protocol, host, port number, and also the path to the resource. All right, so you also need to understand this one because later on when you start to build your own web service, well, you need to know where you're hosting it because that's going to determine the host. You need to know which port number you're using. You need to know which product you are supporting. And you also need to know what is the path URL you are providing to the user. So all of this one will be programmed and developed within your web service. All right, so that's the concept about the URL. All right, so lastly, if you understand the HTTP method, the URL, and then you just need to know about the data. So the data, I already briefly talked about that one, whether it's using JSON or XML or some other things, but then you will need to attach those data with your request, right? So your data will always be sent along with the request. So again, there are different ways to send it, okay? There are really simple ways to send, which is here. Like this is how you send the data using the parameters. Location equals, and radius equals, type equals, keyword equals, API key equals. So that's one way to send it. A lot of the time you can start to see the parameters are exposed in the actual URL, okay? But sometimes we don't want to do this one because you don't want to expose this URL, this parameter. The best example is the username password, right? You log in something, you're sending your username and password to the server, but you don't want to just expose those password in the URL. So there are other ways you can attach data. So you don't have to put the data into URL. You can also post the data and put the data in the HTTP body part. Okay, so that's going to be hidden from the URL and the people cannot see that easily. All right, so anyway, I just want you to know there are different ways to attach the data in the request, depending on what kind of data you're trying to send. All right, so like this example that you do not send the data in the URL, you just attach that at the end of the request. Again, there will be different formats. This one is just simply key value pair. You can use JSON, you can use XML, you can use any kind of your own format. And then this part here, when you start to use HTTP as request, then it will be encrypted, so people cannot really read it, even if they get that HTTP request. All right, and then eventually, when the server get your request and finishing and process the request, and then it will send you a result, a response. The result, the most important part is the status, tell you whether the request was handled correctly or not. And then after that, they will actually send you the result at the end of the response. So you will be able to see that. All right, so that is some of the details you need to understand about HTTP. Okay, to summarize, you need to know HTTP is a protocol. It has request and response. They have syntax and semantics specified by the specification. But then some of the key things you need to memorize. Number one, what is the HTTP request method, get or post? Number two, you need to understand the URL concept because URL specify a lot of things about the API, about the service. And number three, you need to know you need to attach the data using different ways, whether it's URL based or body based. Okay, so that's something, the only thing I think you need to know about HTTP, because when you program your APIs, you will need to specify how these things work out. All right. So now with this knowledge, I want you to kind of have a more understanding about what's going on of HTTP. So previously, I do show you about this request here, right? So I send this request in the browser, and I got this response, right? So, but you don't really see all of those things I'm talking about. So if you want to see those, a best way would be open Chrome. Let's open the developer console. If you go to network, and then you will be able to see all the things going on. So I'm going to refresh my page again. As you can see, there is a request going on. You can click on this one here. All right, so let's take a look at what's happening here. So you can specify, you can find out all these details from the HTTP request. As you can see, here is a request URL. That's the URL I'm sending. Request the method. By default in the browser, it's all GET request. This is the response code. There's the remote address, the IP address of the server, and that's the header about the policy. All right. So if you want to say specific things we're sending from the request, okay, you can look at this one here called request headers. Along my request, I actually send a lot of other things besides all of this information. I'm sending accept language, which is English. I'm sending a cache control, how much cache content I want to accept. I said no, 0. And then other things I'm sending like my user agent. Now you can see I'm actually sending some of the my personal computer information. For example, I'm using the Mac OS. I'm using the Apple WebKit. WebKit is actually the browser kernel used by a lot of browsers, including Chrome. I'm using a Chrome browser, and then I also have a Safari in my computer. All right, so I'm actually sending a lot of this one as well to the server. So these are all the things you put together as an HTTP request. And then the response will have a lot more things, like here, response headers, cache control, content encoding, content length, how much data being sent. They start talking about this response, when this content will expire, and server, all that information. And if you want to see the response data, that's basically the same thing you are seeing here. That's the data attached in the HTTP response. All right, so that is what's going on here. Is one complete communication, request and response, right? So if you understand this one, if you keep this network tab open, all right, so if you go to any website, we go to cpp.edu, you go there, as you can see, there are more requests because you're loading, for example, from the HTTP, the index HTTP, web page first. But that page has a lot of videos and images, text, other things. So that every single of those will trigger another HTTP request. So when you're loading a website, you're going to trigger so many different HTTP requests and response. Every request, you can click on that. You can see what are we sending, where are we sending, what are the parameters, request headers, all of those. And then what is the response? The response in this case is just HTML file so that you can render that in the browser. All right, so that's basically what happens here. All right, so any questions? All right, and sending the HTTP request can be done in totally different ways. Okay, so I'm right now just sending that one through the browser. You can send that from a command line, for example. I go open my terminal. Does anyone know the command to send a simple HTTP request? Very good. Yeah, we do have some good web service experts here. Okay, so I'll call it curl. All right, so see URL, and then you go to http://www.cpp.edu, and you hit enter. All right, and I think that one just somehow is being cached. Let me try different thing. Yeah, it doesn't support it. Let's try a different one. It's being cached, so that's why I just want you to redirect with your local cache. Okay, so what else? We'll try google.com. All right. Okay, so I got a bunch of response from Google server. That's basically the home page you're seeing from browser. Okay, exactly the same thing. For example, if I go to Google, All right, so if you look at the page source, that's basically the same thing. Now the difference is when I seeing that in the browser can render this one and can visualize that one, but in the command line you can't. It's just basically the response from the Google server. The same thing if I do curl using this API here, I can see exactly the same result. So I type this URL. Is that because the support number I changed? Let me try this again. What's wrong with this one? I didn't change anything. What's wrong with it? Something wrong with copy. Let me try it. All right, so this one still works, right? Oscar, I don't. My tabs are not many. You don't see many tabs. Okay, I see some student has so many more tabs than I do. All right. Okay, so what's wrong with this one? Or let me try to add a colon, double quote. All right, so that works. I think some of the characters messed up my request, but you can see the same response. I can see that from terminal. But basically, this command is also following the HTTP specification and then send this request into Google and then display the response here. All right. So, but they are all doing the same thing. Okay, following the same protocol, it's just different representation. In the browser, you can see all of this nicely, but in terminal, you can't see it. All right. But in the future, if I can also build my own web application using my friend end, and I can still send this request to Google server. I can build my own map application, not Google Map. I can build my own. So as long as I have this access to all this backend data. All right. So that's kind of some kind of quick overview about this concept. Okay. So again, HTTP might be new to you. You heard about it, but you didn't know about detail. But at the same time, I want you to know that it's actually not really too that many stuff. Okay, the keys you need to understand are about the method, URL, and then data, how to deal with data, and then JSON also very important. All right, so coming back to this definition, probably you have a better understanding. Okay, so some of this important concept about HTTP web service, okay, more specific to HTTP. I mentioned that it's a service always on. So it's always runs, and then it's a program that can accept your HTTP request, can understand it based on the URLs, and also can send the response back. All right, and every URL will have a certain task to deal with, and then we need to well format all the data in JSON. All right, so these are the basic things you need to build. All right, because think about this one, guys. I hope you didn't misunderstood. I was showing you how we interact with the Google Places API. Okay, how do we send a request? How do we receive response? So, but really the tough job was done by Google. Google built this HTTP web service. I was just showing you how do we use that web service. But for your project, you will be the one that build that service so that somebody else can send requests and response to it. All right, hopefully I cleared that one. So now I'm trying to ask you this one, guys. Let's talk about how we're gonna build it. I don't want to just bore you with all this concept. Let's actually build this web application. So these are the requirements you should have, okay? You need to write this program, make sure it's always running nonstop. You need to make sure that your program can listen to the HTTP requests. Whenever the request coming in, you need to know that from the network interface. And then I told you all this HTTP syntax, parameters, the method, all of it. You need to be able to parse those, understand it, and also send the responses back in a certain format. And also you need to know how to deal with the data, how to parse JSON, how to parse XML or anything else. Okay, so this is the program you will be writing. Okay, so I want you to think a little bit about this program. How are you going to write this one? How are you going to implement this one? For example, I know a lot of you know Java. Let's just talk about Java. Okay, you don't have to use Java for a project, but I want to ask you about this one in Java. For example, how are you going to write a program that always runs nonstop? Can anyone give me some ideas? So right now you got a Java program, you click on the button in Eclipse to run, print, give a result, done. But now you want to make sure your program always runs. How are you going to write it? Okay, well threads, well true, Alec, I like that idea. Yeah, multi-thread. So pretty much that's the answer I'm looking for, right? So the easiest way you can do well true and infinite loop forever, right? It's the easiest way, but you know that's not going to work because when you do the while true, you kind of keep your CPU busy. Your CPU had to stay in the while true loop, and then your CPU really cannot do anything else. So that's not going to work. Okay. So the ultimate solution is multi-threading. That's correct. So basically, the idea is that in Java you can create something called a thread pool. Okay. So you can specify what's the maximum number of threads I want to have. So if some requests coming in, I can, serve them. While you're keeping the pool open and live, your program will not stop. So that's the ideal way to keep this, thing running and up to running all the time. Okay, so you do need to write a multi-thread program using some of this thread pool or maybe something more complicated, right? So we solve that one problem. And then secondly, all right, how do we deal with the request? For example, let's talk about listening. Listening to the interface of your network card in your computer and knowing there are some kind of HTTP requests coming in. Once they coming in, you need to parse that HTTP request and understand all these parameters and then extract all these key parameters so that you can deal with the response. Okay, to write that part of the program, how can you do it? All right, Christian mentioned about the sockets, right? Really good. You need a program with sockets because socket is the lower level that you can program and you can deal with all the network events, right? And then Nu mentioned about event listener, really good, right? So you need to have a bunch of listeners listen something coming in, okay? And if it's coming in, let me look at that from the socket level to break down all the data, to compose them, to see if that's an HTTP request, right? Once I see it's a HTTP request, I need to parse it. Okay, that's when you need to understand the HTTP specification. Did you remember I showed you the page that was the 100 pages of specification? What are the syntax, all of those, what's the method, and get all this data out from the request. Okay, and then after that, okay, you do your work and you send a response. When you send a response, you have to form all the, HTTP specification response and then send this through the internet. When you are sending it, you still need to use a socket, a TCP IP, all of those. All right. So this is the kind of things you need to implement. A minimum set of things you need to implement for a web service. How long do you think it's going to take you if you were writing this one in Java? Multi-thread pool, always running, and listening the network socket, understanding HTTP, parse it, and then form HTTP. How long it's going to take? All semester? Yeah. Yeah, I think if you're gonna do this whole thing completely from scratch, okay, I don't think one semester is enough. All right, so you will need, you work really hard, I guess, at least 2 semesters to get something up and running, but it will be very, very buggy. Okay, just think about how much you need to do for the parser, understand all the HTTP stuff, right? So that's why when we are asking you to build the web service, okay, we never expect you to write every single thing from scratch. The truth is you don't have to do that, right? For example, for HTTP, you don't need to write your own parser. There are already something there. And for the listener, and you don't need to deal with the socket. That's too much details. There already something built there to let you know exactly when the HTTP request come in. And you can directly grab the method, all of this key information you want. I talk about JSON. There are libraries for you to parse all of this. Okay, so all of this thing has been done there. And then the even better case is because people have been building the web services since the past 20 years. And they all pretty much the same thing. They all need to run this service program all nonstop. They all will need to go with HTTP request and response and JSON data. So they're all the same structure. The only difference is I'm trying to deal with Uber data. You're dealing with weather data. You're dealing with Cal Poly data. But our service, the function, the infrastructure all looks like the same. So that's why from 20 years ago, people started to build frameworks to simplify this whole process, right? So we do not have to write every single line by ourselves. We just reuse their frameworks, but build our content on top of that. All right, so that's basically development we're using today. And that's why we start to have this kind of things, right? So we talk about the Java Spring, and some of you did mention about Java Spring. So what is Spring? So what's the difference between Java and the Spring? Well, they're both in the Java language. Spring is just a software framework, or you can think about that software library, but it's not one library, it's a bunch of libraries that work together that provides you all of this parsing, listener, multi-threading, whatever the challenging thing, they already done it for you, right? Ruby on Rails. Ruby is a programming language. Rails is a framework that use Ruby to support the web service. All right. Another good example is Django. Django uses Python, but Django itself has its own library and infrastructure for you to follow. Right. What is the framework you use for Node.js? Some of you probably want to do the Node.js. What will be the good framework for Node.js? Express. Yeah, very good, right? So you can write Node.js also, but Node.js itself is already very simple, but Express make it even simpler. Yeah. So Tomcat, I want to call it a web framework. Tomcat is more kind of web container. It's a sit in between the server and also the web service. It's more how you host all this web applications. And .NET, Microsoft, that's the same thing. All right. So, but of course, there are a lot of new things going on. I haven't really included them. That's why when we talk about web service development today, now you might feel, okay, I never heard about Java Spring. I know Java. What is that? Is that a lot of things very hard to use? Or what is Django? All of this, right? Trust me, it's just not difficult at all. All they're doing is some kind of framework code there for you to reuse so that you don't need to worry about all of this, complicated things. All right, does that make sense? Yeah, exactly. A lot less variable, right? And also, the trend today is all of these frameworks are getting easier and easier. Okay, like the Node.js, it just literally takes, Brett, I think it just literally takes 5 lines of code or even 3 lines of code to get a service up and running. Yeah, exactly. Yeah. Even for Java, it's also really, really efficient. Okay. So I probably will show you more about those examples in the next time. But I really want to highlight that for the whole development, you will need to learn quite a lot of different things. Okay. The framework is one. You need to learn database because most of the web service, you need to have one database connected. And also, the more challenging part to learn is the front end. From what I saw before, most of our students are not very strong in the front end development. HTML, CSS, you have JavaScript. Sometimes you do need some other front end frameworks such as React.js, Angular, or some of the template languages. So you would need to learn a lot. Okay, but that's actually part of the goal for this course. Okay, so remember on day one, I said that I want you to kind of have this project done and help your job application, right? But exactly how, right? So I probably didn't really talk this one. Let me bring this slides back here. So when I talk about the goals of the course, and I do know one challenge you guys are facing. Some of you are thinking about the resumes, right? So you might find a resume very hard to write, especially this section here called languages and skills, right? Or something similar. But this is where you list all your skills, all right? And most of you can easily write a Java or C++. I guess a lot of you can write a Python, okay? And then you suddenly realize I don't have anything else to write, okay? Because you took a lot of courses, but the courses didn't really tell you any of this new language or technology. They're just more kind of theories and concepts. So that's when I started to see students put Windows, Mac, or Linux, or that's when I see students to put Microsoft Offices, all right? So you should never put operating system and the Office stuff in your resume as a CS major. If you're a non-CS major, that's okay. You probably want to put those, but for CS major, it hurts you. Okay, it hurts you. Even for the OS, Linux, I don't think that's anything worth to mention. Okay, because that's not a skill in my opinion. It basically takes you 10 minutes to get familiar with. All right. So you really want to get more things in this category. Okay, you have to, because most of the people have a long list. If you don't have a long list, you will be in a disadvantage. And I know you will be asking me, but our school doesn't teach you that one. All right. Well, then it's all up to you. So you will need to get yourself those lists. If you don't get it, then you won't have disadvantage in your job application. So in this course, when I designed it, I specifically was thinking about this problem, right? That's why I wanted to do a web service, because by building a web service, you will need to use so many other things, okay, besides your Java. Even you do Java, that's fine. You will need to learn Java Spring, okay? You need to do a lot of front-end stuff. Then you need to know HTML, CSS, you need to know JavaScript, jQuery, and then in the software engineering class, or core concept are focusing on this part, version control, you already know this one. And we'll talk about how we do the software testing. So JUnit or some other unit testing. We talk about some of the continuous integration using Jenkins, some other new tools. We talk about the deployment using web services. Maybe we'll talk about Docker, container, or some other tools. So through this course, I explicitly put a lot of the tools into the course. Okay, at the end, it really doesn't matter what kind of grade you're getting. By the way, you will get a really good grade from my course. But what really matters is you will be writing your resume slightly better. Okay, something like this. Besides your Java and C++, you can say I list some of the web stuff. You can say, the web services, AWS and Jenkins, all of this. And that's where you can get all of this extra confidences, right? So, but keep this point in mind, guys. It will take you a little bit of time to learn, but it's really worth it. First of all, these are really fun stuff to learn. I can guarantee it's much more interesting than your, I don't know what they're taking, numerical computing, automata. I don't know how you guys can deal with those courses, but this is going to be so much more fun than those topics. And then they're very practical, and more importantly, you can have those items to put on your resume at the end of the semester. Every single one, you can put that. You might be understanding, oh, do I have time to learn every of those to become an expert? No, you don't have to become an expert to put these items, right? So that's something I want to clarify. You don't have to become an expert to put these items. Nobody can become an expert on all of this, all right? But then you show your experience. For example, people will tell you, oh, can you tell me about your experience about jQuery? And then you said, yes, the time I used jQuery is in a 480 project. At a team project, I was actually working on a backend web services. I was using Java Spring. I was dealing with the database. I didn't touch too much about the front end, but I know two of our teammates were working on front end. We were using HTML, CSS, plus some of the JavaScript libraries such as jQuery. And I do know that jQuery help us to simplify a lot of Java web page, like front end page like manipulation. Okay, that's what you will tell. Okay, you basically tell them, I never used that before, but my team will use that in my project. That's it. But that's totally fine because it shows your experience and it shows exposure to some of the technology. And then you know exactly what jQuery is trying to do. You had that in your project. So now if I ask you to learn jQuery, you can definitely do it. Nobody's going to judge your your level on how much jQuery you know, right? So that's the thing you should keep in mind here about their skill set. And nobody will become an expert on every single item. So you will have your specialty, but it doesn't hurt. Actually, you need to put more item here. The more, the better. Okay, so that's why spend some time to learn these technologies is for yourself to enrich your own resume. All right, so that's kind of my expectation on this technology side. So next time I'll try to show you more specific examples and the web services. I can try to show some Java stuff. I can try to show some Node.js stuff, all of this. All right, so any questions? All right. So can every team type something about the technology you guys decide to use? Java Spring or yeah, can you guys all type something so I can have a good idea? Yeah, I like Spring Boot. I'm gonna show Spring Boot in the class as well. Okay, a lot of MERN stack. MERN stack is mean, right? Is MongoDB Express. Okay, got it. Oh, R means React. Got it. I see. Wow, that's really cool. This is the first time I saw MERN stack. Okay. Yeah. For some reason, I don't have too much good experience with Node.js. I think it's really fast to build something in the beginning, but over the time, I find it sometimes difficult to maintain. Maybe I'm not a good expert on the Node. But Java, I guess, Java a little bit outdated, but still building a web service, Java is a really stable and mature language. Right? A lot of companies are still in, I think most of the major backend today are still in Java. And at least I know you can't really simply use a Python to do a web service. It's not reliable as Java. All right. So on presentation on Thursday, we will actually let's do this, guys. Let's do this. Let's keep talking about the project. Sorry. Let me fix this, guys. Let's keep talking about web service on Thursday because I don't want you to forget about something we talked about today. Let's push the presentation next week. All right, next Tuesday. All right, so I'll send an announcement, guys. Okay, so presentation idea pitch next Tuesday. All right, and then web service examples on this Thursday. All right, because I come back to the presentation, it will be another week. So, right, yeah. So the second assignment will be your presentation. So it will be next Tuesday.